Okay, so we're doing the linear regression, and you can tell because there is a predictor. I'm sorry, a predictor, and then the other variable. Okay, this is what's not in the book is the descriptive statistics. So if I'm going to write this up, I would say for the demographic of, I'm sorry, for the variable of life expectancy, the mean was M in italics equals 70.32 with a standard deviation of 2.64. SD equals 2.64. Okay. And I would do the same for that. That's what that shows. But it gives you numbers and that you generally, in most cases, if when you do yours, you would report, but you will have reported, you would already reported this in a certain section of it. This would go to a separate section of the paper that just has your demographics, age, gender, race, socioeconomic, life expectancy, GDP, whatever it is. Those are in what we call demographics. Those demographics are either descriptives or frequencies. We did those earlier. Okay. When you look at age, you're looking at a descriptive. Okay. When you're looking at like gender, where it's 1 and 2, then you're looking at a percentage. Okay. Age is a number. Let's say, let me give you the difference. Age is a number, like age. I'm 61. Okay. If I put it into a range where I say, like say 15 to 25 and 26 to whatever, and you got 1, 2, 3, 4, and the last one's 15 above, I would click the 50 to above, and that would be run as a percentage, not as a minimum, maximum, mean, and standard deviation. Done with that. So when you break this down, we're looking at life expectancy and their GDP per capita, which means gross national product. Okay, I don't care what it is, and when we do statistics, I don't care what it really means. Those are just what the values are. Okay, you can see in the box right here, it gives you a correlation to start out with. So we look at the Pearson correlation, and we know that life expectancy to GDP is basically at a moderate level, and it's also positive. It's a positive, moderate positive correlation. Okay, and that's kind of like where it lives. This is part of the assumptions where we look at this and we go, if that's 0.999, we have a problem. They're highly correlated with each other. We busted one of the assumptions. Okay, then we come down and there's still some stuff in. Oh, sorry, I keep doing that. I apologize. We're looking at a lot of stuff that we already know. Okay, our value 535 is the same as the one up above. They're nice enough to give it down there. Okay, and that's for the whole model because there's only one. R squared is 29%. So 29% of the variance between life expectancy and gross national product, 29% of the variance is understood. Okay, I don't worry about adjusted star square or the standard error or the change. I leave that alone. The F value is relatively important, but the biggest part of that line is Durbin-Watson. That is one of how you know the assumption, and it should be relatively close to 2. Period. Durbin-Watson should be really close to 2. You're pretty darn close on all of your assumptions. Okay. The only one left is down at the bottom. Now we move into the regression, the ANOVA. We look at the ANOVA, and the biggest thing we want to know in the ANOVA is the significance level. So somebody turn on the mic and tell me, are we significant or non-significant here?
Significant.
Thank you. Thank you. So we know it's significant. Now here's where in the F value, which you will be reporting, there's two DFs. It's degrees of freedom. I'm not going into that tonight because we had too much to do on this page. But in this case, it's the regression versus the residual. In a true ANOVA, it is within groups, and outside of groups. I don't remember the two words, but it looks at both. Okay, you're looking at multiple ways of doing things. Okay, so you would report this as 1 and 244. The total doesn't matter. Total matters only because if you go up to the top, there's 246 participants, right? So basically, you'll see there that they took one out for the regression. There's 244 and it brought to 245. I have no idea why that number doesn't match, and I'm not going to stress. And then you have your F value here, which you're going to round up to 98.07. You're going to go, what is that? Tens, hundreds place every time. You round to the hundreds place. Only in it when you're doing a correlation or the p-value now that you use 3 spots from this point on. Okay? But now you get into the core. Got to get all the way down here to get to the bottom. We're looking at a beta. Okay? When we look at that beta number, it's basically saying in the end, 535, I'm saying 0.3, I'm basically what is that? 54% of the variance between the constant, which is of course life expectancy, and that life expectancy is related to GDP. Okay. And then when you're talking about that box that they want, this is one of the values, this beta right here. I'm sorry. Yeah. The beta right here is what you're looking at. There's only one here. We'll get to the other one. And then there's a predicted here. So then we get to the PP plots, and this will make sense when we pull it up and we put it in the actual thing. You can see the PP plot right here, and you see how those lovely dots are right next to it. That's what you're looking for. That's one of your very last checks. You look at that PP plot. If those dots are real close, you're in business. Now there's 246 here. Keep that in mind when we go to the multiple, and I'm going to show you the difference in why it is okay, but it's not. Okay. So then you look at the scatter plot here, and this is called a Lowe's line. Okay. You see how it's really close to 0? In this scatter plot, it should be really close to 0. And understanding that using the correct amount of participants, or enough participants, but not too many. It's kind of like, you want to be just right. Remember that G power that we ran? That G power is supposed to help you work toward when you do your tests, your assumptions are going to be pretty well met because the power is there. And when I get to the second one, hopefully that'll make sense of what we're talking about. Okay. So now we do in the one in the book, SDP, SBP, age, and weight. Okay. Now, the problem here is that the correlations are extremely high. So you might not be able to run the test the way you're supposed to. You might not meet that assumption. Okay. And then you have to run another test. Your R value is 9.88. The R squared is 97%. So basically, in essence, this doesn't really work. You get data and you can write it up for a thing, but the data doesn't quite meet it. In this class, the data we're given is the data we're running with, whether it's good or bad. You just report what you find. You don't have to stress about it. Okay. All right. So we come all the way across to the Durbin-Watson, and yes, we've met that assumption. You come down here and you have these values the same as they were before, and then you have your beta, 57% and 58% and 43% are related to, what is that? SPP. Now, give us a histogram, and that histogram meets the criteria. It's funny that they're over correlated. Okay, but somebody Somebody pop in and tell me those look pretty close to the line, right? Do those look pretty close to the line?
Yes.
You're right. What's the problem with it? Does anybody know? Somebody give me. I'll give you about 20 seconds to come up with an answer why there's a problem here. I love guesses too. Look at that picture. Remember the other one. Now remember this one. What's the major difference between the two?
Less participants or less data?
Nope. Well, same thing. Less participants. Okay. So you're like throwing the other one throws it at a dartboard that's the size of a wall. This one is throwing it at the dartboard of the size of about this big. So yes, they are highly correlated, but they meet the assumption for this. And then if you look down here, it's on 0. And that's because there's so many numbers. Okay. If I take this and I open it up and I change the fit line to the lows, you see how crazy it is? It's all over the place. And you saw it on the other one. It was really close to the line because there was enough participants to make a difference. The R2 on this is 0. Is 0 because they're all far away from the line. Even though this is different than the R2 that's in there. This is the R2 of the dependent variable of SDP versus the regression, standardized, residual, and predicted. That's in one of the boxes. And it basically is the dots are, I don't know if I can show labels. Never done that before. Add title, text box, show grid, show data labels. I don't know if this will work. Well, there's the numbers. 10, 1, 7. It's all over the place. The data is still good because it does meet all, but the PP plus, it now meets all of the criteria. So knowing what to do and what to do with all these numbers, I've given you a template, and that's where we're going to go through next.